Hi everyone, my name is Mo Saal and also known as Harry. So today we are going to talk about critical points. So today we're going to cover some of the important things about critical points, what are critical points, and we're going to do some of the example questions that I prepared for you. And also there's also a practice question that you could practice on our website. So please make sure that you visit our website and do our practice problems and walk through the content that I share with you. So let's go through it. So these are the topics and the contents that I'm going to cover today for you. So the first is introduction to critical points, and the second is formal definitions of critical points and how we could apply it to real life example. And we're gonna go through example problems. So today I prepared 3 example problems for you, and also I prepare a practice question that you could practice after this. So let's go through it. So what are critical points? Well, to put it simply, critical points are places on graph where the slope becomes 0 or doesn't exist. So what does this mean for us, right? What does it mean in simpler terms? Well, basically, critical points are just turning points where the graph is increasing or is decreasing. As is stated here, in simple terms, they are where the function might stop increasing or start decreasing, or where the graph flatten out, which is where like the gradient is 0, or the gradient is positive is increasing, gradient is negative is decreasing, and the one graph is flattened out is 0. So these points are important. Why? Because they help us understand how a function behaves and where important changes occur. So now I'm going to talk about how we could apply it to real life example. So, well, of course, you know about critical points. Yeah, you understand the concept. But where do we apply it in real life? Well, we could apply it in many different fields, such as in business, engineering, physics, or even in AI, artificial intelligence. So in businesses, companies use them to find the level of production that gives the most profit. So basically, this is maximizing profit. So this is when the businesses use it to maximize their profit. And for engineering, they help identify where the process is not efficient, and they try to maximize efficiency basically. So basically, it's used to maximize or minimize things. And in physics, it's used to show the like the motion of something, right? So it could be the speed of something. It could be it could usually be the projectile motion of like things happening. And how do we use it in artificial intelligence that's been going viral in the past decade? Well, in AI and data science, critical points are used to find the best model setting that minimize the error. So it's mostly used to maximize, minimize, or to show how it works. So what is the formal definition of critical points? Well, to understand formal definition, we should understand the basic concept of critical point. As I said before, as stated in the video in the back, it stated that a point is a critical point only if the function follow these conditions. So these conditions must be satisfied in order for a point to be a critical point. So what does it need to be a critical point? Well, it needs a function. A function must be defined. So the function must exist, it must be defined. So, and then if we differentiate the function, the differentiation of the function should be 0, either 0 or it should be undefined. So students get really confused in this part because they got confused with the fact that the differentiation of the function must be undefined, not the function itself. The function must always be defined, but the differentiation of the function could be undefined or could be 0. That's how we find the critical points here. So this is the formal definitions of critical points, and we're going to talk about how we could find critical points and important things that you could remember. So in this case, how do you usually find critical points? Well, it's quite easy. Critical points are value of x where the derivative of a function is either 0 or undefined. So basically, we just have to differentiate the functions and equal it to 0. So they represent the places where the slope of the tangent line is horizontal or where the function has a sharp change in direction. So it's either increasing, decreasing, or flattens out, as stated before. So the step by step, how do we find it? Well, first of all, what you have to do is differentiate the function and solve for derivative is equal to 0 or undefined. And that's how easy it is. You just have to do that. It's only 2 steps. But there's important things that you could remember. So if the differentiation of a function is 0, it could be horizontal asymptote, or maximum point or minimum point, as you can see from here. Minimum point or maximum point, or it could be horizontal asymptote here. So these are 3 things that could happen if the differentiation of a function is equal to 0. So what about if it doesn't equal to 0? If the differentiation of a function is undefined, what happens? Well, if a differentiation of a function is not defined, it's not differentiable, it could be curves, sharp corners, or vertical tangent, as you can see from here. Here, you have to remember that curves is not same as the sharp corners, because a lot of students get confused between the two. So you have to remember that curves go like this, and corner is basically a straight line, like a V shape. However, curves is more like 2 graphs, like intersecting in the middle, basically. So that's what you have to remember. Another thing that you need to remember is that discontinuity is not a critical point. So students believe that discontinuity is also a critical point, but it's not, because they believe it because at that point the function is not differentiable. But so okay, you're right that the function is not differentiable at the discontinuity, but why doesn't it a critical point, you might ask? Well, it's because of the fact that at a discontinuity, the function does not exist. The function is undefined. So the function must always be defined for a critical point to exist. So at the discontinuity point, the function simply doesn't exist. So it's not a critical point. Example 1. So this is the questions which I think is pretty easy for you to do. So which is x cubed minus 3x squared plus 2. So as I said before, we need to go step by step. So step 1 is to differentiate the function. So if we differentiate the function of it, it got 3x squared minus 6x. And we solve for x, the differentiation of the function equal to 0. So if we equal it to 0, we got 3x squared minus 6x equal to 0. And then we try to solve for it, solve the equations, and we got x equal to 2 or x equal to 0. So usually we draw a number line, as you can see from the graph. We draw the number line like this to get a better understanding of what's happening. As you can see here, the polynomial function is defined for all real numbers, all real values of x. So these are the critical points, right? So we could also like check the points before and after of the critical points to make sure that we understand the bigger picture. So if we just plug it in and do this, right? If we find the before and after points of the critical point, you can see that before the 0 is plus, which means that the function is increasing, which you can check it from the graph. As you can see here, the function is increasing before 0. And then at 0 to 2 in between, the function is decreasing because it's negative. So as you can see here, it's decreasing again. And 2 to infinity is increasing again because it's positive numbers. So that's how you got to check whether your function is maximum or minimum in the later chapters. So example 2, this is how to find the critical point for following equation. This is a rational function. So like x squared minus 1 over x. How do we solve for it? Well, it's pretty easy. We just have to differentiate it first. So we try to, before differentiating, we try to simplify it first to make it much more easier. So after differentiating, we got 1 plus 1 over x squared, and we try to solve for 0. And 1 plus 1 over x squared is equal to 0, but it's not possible. Why? Well, the thing is, it's not possible because in the domain it doesn't equal to 0. So if like the 0 is not in the domain, it's not possible. So there is no critical point in this domain itself. So this function does not have critical points. Example 3, and this is the last practice question for you. So determine the critical points of this. I'll give you 3 minutes to do this one. Okay, time's up. So this is a solution of how you get to the point of how to get to the answer basically. So how do we find the critical points of this? Well, as usual, we try to differentiate it, but this time you have to know that differentiation is not as easy as we used to do it because it has a root, so we have to simplify it first, right? And after differentiating, what we get is 1 over 5 to y minus 6 bracket into y squared minus 6y over negative 4 over 5. And we try to just simplify again, which equal to 2y minus 6 over 5 bracket y squared minus 6y over 4 over square 4 over 5. So, and then we solve for a derivative when it's equal to 0 or undefined. So in this case, as you can see here, 2y minus 6 is equal to 0, which makes it equal to y is equal to 3. And when we solve for the denominator, it is 0 and 6. However, we need to know as well that the reason for moving the term to the denominator as we did in the first step is to make it clear the last two critical points are critical points because the derivative does not exist at those points and not because the derivative is 0 at those points. Also note that they're critical point because the function doesn't exist in these points. So therefore, the critical point in the case are 1 equal to 0, 3, 6. So that's it, everybody. Thank you for watching this video. And if you want to practice more, there are more like practice problem for you on our website. And if you don't understand it yet, you could check out more material that we have gathered for you on our website. And there's also videos that you could check out for other chapters too. So thank you and see you for next video, I guess.